Alright, ladies and gents, this is 1.1, the question in the notes that if you don't have a TI-84 or any TI calculator, really can't do without a different way of doing it. So we're going to talk about how to do this problem using Desmos. Okay, so we talked about it a little bit in class. But this one website here, you're probably going to want to bookmark it, or at least know how to get there every time, because this is the calculator, graphing calculator, that you're going to be able to use through the rest of the course. That is free. You don't have to worry about it. It's on your computer. Just go to the website and you can use it. But what you're going to have to know how to do is make sure you're using it correctly, and that's ultimately what what this video is about, making sure you know how to type stuff in, figure things out, maybe, you know, zoom in, zoom out, and what to kind of look for in particular things. So what we're going to do is we're going to work on this particular problem here, and I think we're going to work on, I don't care about the table set and the calculator zoom because that doesn't matter with Desmos. We're going to work on this problem here in Desmos as well. So what we want to do is let's go to desmos.com. I am going to split screen here, and I already have Desmos popped up. Okay, if you didn't know what you're looking for, you go to this website here, and it says Let's Learn Together, and then it says Graphing Calculator. You click on the Graphing Calculator, boom, and then it looks like this. Now yours might look bigger, right, because it's a bigger window, but for me, I'm just dual screening here, split screening, ba-boom. And okay, let's go. So we talked a little bit about this the other day, where I can't use variables t's and c's and stuff like that. I can only use y's and x's, so x's and y's in my writing of my stuff, right? So I'm going to change c of t to y. I'm going to change all of my stuff over here to just x's. Okay? All right. And let's graph it. Okay, so let's graph that sucker. And how do we do that? Well, I'm not going to care about the c of t equals or y equals. I don't care about that. I just care about this stuff that's over here. Okay, like that 1/3 and so on. So let's type that in. So I'm going to do 1 divided by 3. Once I do 1 divided by 3, you'll see that this is actually a calculator as well, so you could use it as a calculator, not just a graphing calculator. I'm going to scroll over, so I did 1 divided by 3, and then I got to hit the right key to get x. I got to hit the shift 6 key to get the third, okay, and then I got to scroll over to get the minus, all right, 2x squared, so then shift 6 squared. Okay, now, if you don't want to do the shift 6, okay, and you want a squared there, you can hit this little keyboard. It'll pop up, and you can just hit this a squared, and it gives you the squared key already, okay? So you can do that too. Minus 2t, which is 2x, right? Or minus 2x, sorry. And then plus 50. Plus 50. All right. So now, I'm going to make this a little bigger so you can see. Bring that down, and it looks like you have like a straight line almost, okay, but you don't. So what you want to do is you want to zoom out. So now your fingers, if you do this and you start low or start wide and then bring it close, you're zooming out, okay. In order to zoom in, you start close and then you spread apart, just like your cell phone, okay? It literally is the same as your cell phone. Me, I don't have a touchscreen desktop right here, so I'm going to use my mouse. I don't know if you can see my mouse. It's my mouse. And I'm just going to use this scrolling thing. And I'm going to scroll backwards, okay? And so again, you use your fingers or however you want to do that, but you have to zoom out. And then when I zoom out, you can definitely see that this graph, okay, is it goes up, 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 reaches a point here, comes down, reaches another point, and then goes back up. I don't care about the graph. Oops, sorry. I don't care about the graph like up here, and I don't care about the graph really down there. I care about the graph in the middle, where it does its like up and down kind of, whoa, man. That's what I care about. I don't care about the highs and lows. We'll talk about later on this year. We will care about that later, but not right now. And what do I want to do? Well, I want to use this graph now to figure out what I need to do for the actual equation, or like this work over here. So, what does that mean? Well, it says, what does C of 3 mean? Well, what does this actually equation mean? If we look at the equation, it says C of t is equal to 1/3 t squared minus 2t squared minus 2t plus 50. Whew, that's a lot. Well, what this means is t is the time. Okay, t is equal to time. T is always equal to time. Okay, it's always equal to time. We don't use any other variable to represent time other than t. Or maybe seconds for S for seconds, but that's still weird. T for time. Okay? And then what does this represent? Well, this is the total number of cards. Total number of cards that Mr. Bean has after T days. Okay, so after 1 day in this tournament, he has however many cards. After 2 days, he has however many cards. Well, what's this first problem? This is after 3 days. How many cards does he have? Well, now I'm going to go back to my trusty graph. Okay, I'm going to zoom in a little bit to kind of get this a little bit better in my window. Alright, zoom in a little bit better. Now, here's what's cool. If you click on the graph with your finger or with your mouse, a box will appear with 2 numbers. And the numbers are x comma y. Okay? X comma y. So if I want to find C of 3, I want to find out what it equals. All I have to do is click on the graph to find where the first value is, positive 3. And so if I keep going, I'm going to find a positive 3 somewhere in this area here. See if I can find it. And somewhere, right there. 3 comma 35. So this is 35. Okay? So that's what the value means. But what does this actually mean? Okay? So this means it's 35 cards left after day 3 of the tournament. Okay? So, after the 3rd day of the tournament, according to this graph, he has 35 cards left. Alright? Cool beans. Let's find out what else we got to do now. Let's go back. I got to find what C of t is equal to 40 means. Okay? C of t is equal to 40. So, C of t is equal to 40. Well, if t is time in days, what do you think the 40 means? Well, hopefully we can see that it's now the reverse. This means this is the number of cards he has left after t days. Like, we don't know how many days. We have to find it. Okay? So, what value is this? Well, if t was my x in the previous example, and that number over here was my y in the previous example, well, that's the same thing. This is our x, this is our y. X, y. It's always that way. Always, always, always. So, I have to find when y is equal to 40. Well, how do I do that? Again, I'm going to click my graph, and I'm going to move until the second number is as close to 40 as I can get. Okay, so we get 40.07, so about 2.11. About 2.11. So that's one answer. But let's think about this. Well, when it's 40, there's actually a line cutting through here. Okay, there's actually a line cutting through there. Well, can I graph that line? Well, yeah, sure I can. How do I do that? I'm going to go back over here to my graph piece. Okay, let me do this real quick. I'm going to go over here. I am going to hit enter on this one and make a new box, number 2. What do I want to graph? I want to graph y equals 40. So if I just type in the number 40, let's do y equals, I guess it's not reading it. So let's do y equals 40. There we go. And there's my line, that blue line right there. So that's pretty cool, huh? Yeah. So now, what's even cooler, okay, what's even cooler is, oops, that's not cool. Yeah, let me do this. Okay. So what's even cooler is if I actually touch this graph, the red one and the blue one, you're going to see some cool things happen. You're going to see some dots appear. Here, 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 and here. Here. Well, what do those mean? That is when, those are important pieces of the graph. Okay, of the blue graph, of that y equals 40. All right, and what else can that tell me? Well, that tells me that this piece here is actually going to be, if I click on it, 6.186, comma 40. Well, this is the amount of cards, so then this is the time. So after 6.186 days, he will have 40 cards. And then 2.111. That's another time that he will have 40 cards. Now you might be thinking, well, there's actually a third one, and that's over here. But it's negative 2.297. I can never have negative time, so this one here just doesn't matter. We don't use that one. We will use this one and this one. Okay? So that's your answer for part number B there, or letter B there. Let's go back and see what it was. Oops, wrong button. Okay, so yeah, there you go. What does the y-intercept mean? The y-intercept of the graph, the 40 is not the graph. That's something we just graphed. This is the actual graph. What does the y-intercept? Well, the y-intercept, let's erase all this stuff, is this value right here. It's at 50. So the y-intercept is equal to 50. What this number tells me is this is how much or how many cards he started with. The y-intercept is always the amount you start with, no matter what. Okay, you need to know that. The y-intercept is always the amount of money, amount of cards, amount of items, amount of things, amount of whatever that you're starting with. Okay, so in this case it's 50. So that wasn't too bad. Let's go to the next one. Let's see what the next part is. There. What is the lowest amount of cards that he had? What is the lowest amount of cards that he had? Okay, let's think about this. From 0 to 7 days. Remember, from 0 to 7 days. What's the lowest amount of cards that he had? The smallest amount of cards that he had. Well, let's look at the graph. Okay, let's zoom out a little bit. Yeah. Here's 0. Right? Down here. So he never hits 0. If I click the graph, the red one, you're going to notice that at the bottom of this hill, there's a dot that appears. Actually, let's do that. So because this dot appears right here, this is what we call a minimum. You don't need to know this now. We'll talk about it later on as well. But it's a minimum. So this is the minimum amount of cards that he had. So the minimum amount of cards that he actually had was approximately 30. This, it's not an equal because it's 0.869. So it's actually a fraction of a card, but you can't have a fraction of a card. So if you've never seen this before, it's an equal sign that's like, it's called an approximate symbol. Okay, so approximately 30. That's the minimum amount of cards that he had during the 7-day tournament. All right, let's go on to the next problem. What is the next one? We did that one. We did that one. Okay. Apparently this dude likes to gamble. Let's go on and clear this thing out. Let's X and X. Okay. Oops. All right, let's clear that away. That's a lot of time. 15 minutes. Oof, sorry. He has a 1-day layover in Vegas. He decides to gamble continuously for that time period. The following function represents his total money over that day, where T is measured in hours. So again, T is for time, but in this case, we're talking about hours, not days. So this function, I want to graph this function. All right, so let's graph this function. Remember, I can't use T and B's and all that stuff. I could use X's and Y's. So I'm going to use X's for my T's. I get negative 0.02x to the 4. Now, you can use that second 6 button to get your 4. But what if you didn't want to use second 6? You come down to the keyboard. You hit the A to the B. A to the B. C to the D. I don't know. I don't know if it's a rhyme or not, a rap or something. I don't know. You hit this button, it automatically makes it into a superscript, and you can make that number whatever you want to, 45 or 4, whatever you want it to. Okay? So now x to the 4 plus 19x plus 180. All right? Plus 180. I'm going to close this a little bit. And make sure you... One thing you guys got to make sure is make sure you do type it in correctly. There's a lot of times where you're like, I don't get what you got. Well, because you didn't type it in correctly. Like, that's pretty easily solved. You just got to pay attention. All right, I am going to look at my graph here, and my graph looks like it goes up and does something up here and then comes down. So let's see if I can find out what it does up top. Oh, okay, cool. So now it looks like it goes up and comes down. Now, your graph might be really skinny, and you might be like, that sucks. Like, it doesn't get to show me anything. Here's what you can do. Over here, where it says the wrench and all that stuff, if you click the wrench, it gives you abilities to change your axis, like your axis values. So if you look at this, it goes from negative almost 200 to positive almost 170. But I'm only really dealing with, if you look at it here, I'm only really dealing with negative 20 to 20. Like, anything outside of that, I'm never going to touch. So I'm going to change my values to negative 20 to positive 20. So negative 20 to positive 20. Cool. All right. Now it looks kind of cool. Like, my values looks a lot better because I widened my graph. Or actually, I zoomed in a little bit, if you want to call it. If I zoomed into my graph instead of it being so spread out. So now it goes up, does a weird kind of shape, and it comes back down. The first problem that it says, what does B of 12 mean? And find it. What does B of 12 mean? And find it. So, B of 12, what does it mean? And find it. Well, this variable in here is technically T. Well, what does T stand for? T stands for hours. So 12 is hours. So this is 12 hours. Okay, we know we're dealing with that. Now let's find it, and then we'll talk about what else it means. So I want to find B of 12. So I got to find out when the first value, x, is 12. So right in here, somewhere right there. Oh, well, keep going, keep going. Oh, right in it there. Negative 6.72. If you look at that, you can see that 12 comma negative 6.72. Negative 6.72. What does this mean? Well, this is how much money he has left after 12 hours. But negative, you can't have negative. Well, I mean, I guess you can if you owe people money, right? But the casino doesn't want you to owe them money. They're going to say that you ran out of money. So this dude ran out of money. Oh, I can't spell money. Money. So you can leave it something like this as long as you explain what you're talking about. But basically the dude's broke. After 12 hours, he ain't got no money. He ain't got no money left. Alright, let's find out what the next problem is, or piece of this problem is. B of t equals 80. B of t is equal to 80. Again, this is t in time in hours. So then this is amount of money. So I want to find out when he has $80. $80. So let's find out when the second value becomes 80. So somewhere in this area. And you're just guessing right here. Remember, what we can do is I can make another equation to y equals 80. I can click on it, and it's right there. So that tells me that after 11.18 hours, he has $80 left. This dude is broke as a joke. All right, that's what that line tells me. You got to remember how to do this. This is the last time I'm showing you this kind of stuff. I'll show you some more stuff with Desmos later, but this easy stuff you got to get to know pretty quick. What does the y-intercept mean? What does the x-intercept mean? Well, if I click on the graph, the blue one, the y-intercept pops up, 0, 180. 0, 180. What does this mean? This is how much he started with. He started with $180. The dude walked into the casino with 180 bucks, and he was like, let's go. And then, what happened? Well, what does the x-intercept mean? The x-intercept is down here. And what does that mean? That means that after 11.943 hours, he went bankrupt or broke. Okay? He broke. He lost all his money. All right? What else we got to find? What else we got to find? What's the most money that he had? That one's pretty easy. Hopefully you can see that. Okay? What's the most money? Well, the most money's up here. After 6.193 hours, he had $268.25. I rounded because that's okay. All right? That's how much he had. If it was me, if I started with 180, I'm up to 268 after 6 hours. I'm probably done. Okay? That's not a really good return after 6 hours, but he didn't walk out. He wouldn't have walked out with any less money than he had. Okay? But instead, he walked out after 11 hours with no money. He can't even Uber home. He's got to walk. He's probably got to sell his sneakers because he ain't got no money to, like, eat or something. Dude's broke. All right? I think that's it. What else I got to do? Nothing. That's it for this video. I'll get to the next lesson and show you how to use Desmos as well. But until then, deuces.